Hi everyone, welcome to my channel, Tutorial Test Prep. Today we'll be going over Ottocento number 10, Area and Volume Scale Factors. The goal of the Ottocento course is to teach students everything they need to know about the digital SAT Math exam. Please see the link in the description to download this video's worksheet for free. Let's get started. Okay everybody, so take a look at these two squares. One square has a side of 4 inches and the other square has a side of 12 inches. We can calculate the area of each of these squares by doing s squared. So the area of the small one is 16 inches squared, and the area of the big one is 144 inches squared. Now you will notice that the side length, 12 and 4, differ by a factor of 3. The big one is 3 times as big. The area differs by a factor of 9. Now you may notice that 9 is equal to 3 squared. This concept is not just true for squares, it is true for any pair of shapes that are similar. This is the concept we're going to be going over today. So a couple things before we go over the main idea is these are some common linear measurements, like one-dimensional measurements that you might run into on the DSAT in general. So length, so like a side length or an edge length, something like that. Width, height, perimeter, radius, diameter, and circumference. You'll notice I put perimeter in bold. That one's really important. That shows up a lot on the test. Hopefully that makes intuitive sense. Perimeter is just a sum of lengths. So perimeter is also one-dimensional. You don't need to memorize these. You just want to be familiar with them. Okay. Now another thing that confuses people is that these shapes are always similar. They do not need to tell you. So in other words, they always have the same shape, regardless of whether they tell you it's similar or not. So any 2 circles are always similar, 2 spheres are always similar, 2 squares are always similar, and 2 cubes are also always similar. Now, what lots of people do is when they see problems about a pair of spheres, they like go to the reference sheet and they start using volume equals 4/3 pi r cubed and stuff like that. And while you can solve a lot of these problems that way, you'll realize that that takes a lot longer. So it's much faster if you recognize that these shapes are always similar to one another. Now, in addition to squares, really any regular polygon is pair of regular polygons are similar to each other. So you might run into equilateral triangles. That's a pretty common regular polygon on the SAT, equilateral triangles. You also could run into like a pair of regular hexagons or a pair of regular pentagons, though I've never seen that. Mainly the 4 on screen are the really important ones that I want you to be familiar with. Okay, so here are some abbreviations that I'm going to be using for the rest of the video. So please just take a note of this somewhere. So the scale factor, we're going to use SF. Linear scale factor, we're going to use LSF. Perimeter scale factor will be PSF. Area scale factor will be ASF. And the volume scale factor will be VSF. Okay, so what is a scale factor? So a scale factor in geometry is found by dividing a big measurement by a small measurement. So a scale factor is equal to big over small, put simply. Now, in geometry, you might have actually learned, and this is like the proper way to think of it, is you do a dilation and you do new divided by old. However, the SAT doesn't really force you to do that. As long as you get the answer right, they don't really care. And I think thinking of it this way is pretty convenient because if you do big divided by small, the vast majority of the time on the SAT, the scale factor is going to be a whole number. So wouldn't you rather just use 3 instead of 1/3? I feel like that's just easier to think personally. So you don't have to do it my way, but I suggest you do because it's going to work out well a lot of the time. So big over small. Okay, this is the most important slide in the entire video, so please make sure you write this down. So the length scale factor, that is so common, we're going to use just an arbitrary letter to represent that. So we're going to call the length scale factor capital K. The perimeter scale factor, well, perimeter is just a linear measurement. So perimeter scale factor is just equal to K. I didn't even need to make a separate equation for that. I'm just emphasizing that again, simply because College Board likes to ask about perimeter. Now, these next two are by far the most important. So area scale factor is equal to K squared, and the volume scale factor is equal to K cubed. Now you'll notice this is kind of easy to remember. For one-dimensional, K to the 1. For two-dimensional, it's K to the 2. And for three-dimensional, it's K to the 3. Now, I want to point out that 3D shapes can also utilize an area scale factor by looking at their surface area. So if you see the word area whatsoever, you probably need to find an area scale factor. So you can kind of see we're probably going to have to solve these equations and do stuff with them. So we're probably going to have to either square a number or do the opposite, take a square root. And then if we're working with volume scale factor, we'll probably have to cube a number or do the opposite, take the cube root. So that's everything for this slide. Definitely pause this video and make sure you write this down before you keep going. All right, so here's going to be kind of the thought process. They could give you a question where they ask you to just find the scale factor or something, but most of the time they're going to ask you to find a scale factor and then use it to find a missing quantity. So here's just kind of a rough conceptual breakdown of what that's going to look like. If you have the small value and you want the big one, well, the way we define our scale factor, it's always going to be a number bigger than 1, the way we defined it. So we're going to multiply by the scale factor. So if you start with the small, multiply by the scale factor. You'll see what I mean when we do a problem. And if you start with the big and you want the small, you're going to do the opposite. You're going to divide by the scale factor that you came up with. So that's how a lot of these problems are going to shake out, is we're going to figure out what it's asking, compute a scale factor, and then use the scale factor to find some sort of missing measurement, say a missing height, or a missing area, or a missing volume, or a missing length, something like that. So that's basically it. We're just going to now do like 5 examples, and then we'll do the review. Okay, so take a look at this problem. First thing I notice is that they tell me they are similar, so that means I can use this concept. It says that rectangle B has a side length that is 5 times the corresponding side length of rectangle A. Okay, that is telling me the length scale factor, which we call capital K, which is 5. Now I notice the question is asking about area. So I'm going to compute the area scale factor, which is K squared. So for this one, we do 5 squared, which is 25. So the area scale factor is 25. And they gave me an area of 200. And now kind of the way that second sentence is phrased, I'm noticing, okay, it kind of sounds like rectangle B is the bigger one. So I want rectangle A, which is the smaller one. So we're going to do 200 divided by 25, like we talked about in the last slide. And we should get 4. And that should be the answer for this one. So you see, guys, there is no need to pull any area or volume formulas from the reference sheet. You can solve lots of problems just by understanding this idea. All right, let's look at the next one. So it says that, that they're similar, so we can use this concept. And it says that we have an edge length that is 3 times the corresponding edge length of prism A. Okay, so that is telling me it's bigger than 1, so it fits our definition. So that is telling me a length scale factor. We said edge length is a linear measurement. So the LSF, which is K, is 3. Now it's asking us about volume. So we want to find the volume scale factor, which we already talked about, is K cubed. So the volume scale factor is K cubed, in this case 3 cubed, which gives us 27. You can just do that on a calculator. So now we're like, okay, do we multiply or divide by 27? Well, reading the question, it certainly sounds like prism B is the bigger one, and we've got the smaller one. So the volume of prism A is 6. So we're going to do 6 times 27, not 6 divided by 27, because we want the bigger one. So 6 times 27. And that will give us 162, which is the answer for this guy. Great, let's keep going. Okay, now this one doesn't tell me it's similar, but you'll notice it tells me that the picture frames are each in the shape of a square. And remember earlier we talked about squares are always similar. So they're similar. Even though they didn't tell us, they kind of told us indirectly. Okay, now this little part here is talking about, see the word times, and I see area. It seems like that is telling me the area scale factor. So the area scale factor is 49. Remember we talked about that the area scale factor is equal to k squared. And this question is asking about side length, so I probably want the length scale factor. So now we will, we need to get k by itself. To do that, we're going to take the square root of both sides. So the square root of k squared is just k, and the square root of 49, you can put that in a calculator, or hopefully you know your times tables, is 7. So the length scale factor is 7. Now we can work with that number they gave us, 63, and we go, do I divide by 7 or do I multiply by 7? Well, it certainly seems like how it's phrased, that frame A is the bigger one. Frame A is 49 times bigger than frame B in terms of area. So we are going to divide to get that smaller one. So 63 divided by 7 gives us 9 inches. And that would be our answer. Great, let's keep going. Okay, this one's a little bit more challenging now. So it tells us we've got volleyballs in the shape of a sphere. Remember, spheres are always similar, so we can use this concept. Volleyball A has a volume that is 64 times the volume of volleyball B. Okay, it sounds like that is telling me the volume scale factor. So the volume scale factor is 64. And remember, the volume scale factor is equal to k cubed. So to solve for k, when you're given the volume scale factor, we're going to do one step of algebra just like before. We're going to take the cube root of both sides. We'll go over how to do that on the calculator later. So the cube root of k cubed is just k, and the cube root of 64 is 4. So be very careful with that, guys. Lots of people, they might have seen the 64 and taken a square root and said 8, but that is not an area scale factor. This is a volume scale factor, so we have to take the cube root to find k. Now the question is talking about surface area. So we now need to do another step of work and find the area scale factor. So the area scale factor is going to be equal to k squared, which in this case would be 4 squared, which is 16. Now I read the question and it seems like volleyball B is the smaller one. So I'm like, do I do 12 times 16 or do I do 12 divided by 16? And we want the bigger one. So I believe we're going to do 12 times 16. And we get 192 square inches, which would be our answer. Great. Okay, another thing they will do to make these a little bit harder is they will give you a table and actually make you compute the scale factor. It really just adds like one more step of work, okay, as long as you understand that a scale factor is big over small. So for this one, we're going to look at the table, and they give us the volume, so that is, we're going to use that to find the volume scale factor. So the volume scale factor is big over small. 2250 over 18. Put that in a calculator, it gives me 125. Now, kind of the crux of all these problems, guys, is finding k. So remember, volume scale factor is k cubed. So we are going to once again take the cube root of both sides, and we should get k is equal to 5. And now the question is asking about diameter, which is a linear measurement. So we are going to use the linear scale factor. And we're like, okay, do we do 8 times 5 or 8 divided by 5? And it sounds like, not even sounds like, we look at the table and it seems like looking at those numbers that cylinder B is the bigger one. So if we have cylinder A, the smaller one, we're going to have to multiply to make it bigger because the way we define our scale factor is the number bigger than 1. So we're going to do 8 times 5, which is 40 inches. And that would be our answer. Now, I wasn't doing this in the slides, guys, but I highly suggest you either draw a picture or if there's a table, like just kind of put the information side by side on the table just to see if it makes intuitive sense, because it's really easy to make a tiny mistake, usually just going the wrong way or something. So like, let's say you divided by 5 and you got like 1.6. You would look at 8 and 1.6 and be like, okay, this doesn't make any sense. If the volume got bigger and they're similar, certainly the diameter should have gotten bigger. But see, I look at this and I go, okay, 18, 2250, that's getting bigger. 8 to 40, that's getting bigger. And you could even type this into Desmos really quick just to like triple check that it's right. So K was 5, and we did 8 times K, the linear scale factor, and we get 40. And then 18 times K cubed, the volume scale factor, and we get 2250. So it certainly seems like it checks out, and it certainly seems like we did a good job. Okay, that's it. Time for the final review. Remember to download the free final review worksheet using the link in the description. Try to complete the worksheet yourself before watching the rest of the video. And I highly encourage you to ask relevant questions about this topic in the comment section. Let's switch to the whiteboard and start with the final review. All right, let's get started with question number 1. So it's talking about rectangles. So let me just draw like a small rectangle and then a big rectangle. And just based on the way it's phrased, rectangle B has a side length that is bigger. So I'm going to call B the big one. And I'm going to call A the little one. Okay, so this part right here, side length that is 8 times the corresponding side length of rectangle A. That is telling me the linear scale factor, which we called K, and that is 8. The question is asking about area, so we are going to do the area scale factor, which is K squared. So that is 8 squared, which is 64. And now it tells me that the area of rectangle A is 32. So it certainly seems like we want to find rectangle B, which is the bigger area. So we're going to do 32 times 64. So let's write that down. The area of B is equal to 32 times 64. And let's see what we get. 32 times 64. 2048. I believe that is right. Okay, let's keep going. Okay, once again, I'm going to draw like a tiny trapezoid and a big trapezoid. And trapezoid B has an area that is 81 times, so that sounds like B is the bigger one. So let's label B as the big one. And the height, okay, so this part here, it seems like they gave us the area scale factor. So the area scale factor is equal to, which is equal to K squared, is equal to 81. Now we are going to get K, we're going to take the square root of both sides. And just to kind of show you guys, if you press SQRT, SQRT, SQR, and then T, it'll do a square root. So we get 9. So K is equal to 9. And it says the height of trapezoid B is 36. Okay, so for this guy, we have 36. And that's the bigger one, and we want the smaller one. So we are going to, and that is a linear measurement. So we're going to divide by 9. And again, you can just do that on a separate line. This will get harder to do in your head as the numbers get messier because we're going to start having fractions and stuff soon. So this one should be 4. So I think the height of A is equal to 4, and I believe that is our answer. Great, let's keep going. Okay, cones. Okay, so let me draw 2 cones. So I'll draw a little cone and then a much bigger cone. Tells me they're similar. And has a radius, that's a linear measurement. That is 11 times the radius of cone B. Okay, so that is a length scale factor, which is K, and that is 11. This question's asking us about volume, so we want volume scale factor, which is equal to K cubed. So we're going to do 11 cubed, and let's see what that is real quick. That is 1331. And this time, A is the bigger one. And then B is the smaller one, just based on how it's phrased. And we are going to, because we have the bigger one, 6655. We're going to divide by 1331. So let's do that. 6655, 1331. And we get 5. So we use the volume scale factor on the volume there. And our answer, the volume of cone B, should be 5. I believe that's right. Great, let's keep going. Okay, pyramid A and pyramid B are similar. Okay, let me draw a little pyramid. And then a much bigger pyramid. Doesn't have to be square. I'm just, just an informal drawing. Just so that we don't get mixed up on big and small, right? And this time it seems like A is the bigger one. So let's label that A. And B is the tiny one. And this sentence here is telling us a volume scale factor, which we said is equal to K cubed. And to solve for K, we are going to take the cube root of both sides. And we get K equals, and if you want to do a cube root on Desmos, you can do CBR and then press T, and it will do a cube root. Very convenient if you're using a keyboard. 343. The cube root of 343 is 7. So K is equal to 7. This is asking us about height, which is a linear measurement. So we are indeed going to use the linear scale factor of 7. Let's see, pyramid A has a volume, pyramid B is 12. So to find the bigger one, we are going to multiply by 7. So let's do that, 12 times 7. And we get 84. So the height of pyramid A is equal to 84. It's 7 times as big. Great, let's keep going. Okay, we've got 2 cubes, 2 sugar cubes. Remember we talked about, guys, cubes are always similar. So these 2 cubes are similar. I don't need to be told that they're similar. I know that cubes are always similar because they always have the same shape. It's just a property of a cube. So it has a surface area that is 4 times the surface area. Okay, so let me draw some cubes here. And I believe cube B is the bigger one based on how it's phrased. And it says that we have an area scale factor, because surface area is area. It's just the area of all the surfaces added up. So this is k squared, which is 4. We're going to take the square root of both sides. SQRT, the square root of 4 is 2. But we can't stop there because the question is asking us about volume. So we need to now go and compute the volume scale factor, which is equal to k cubed, which is equal to 2 cubed, which is 8. So the volume scale factor is 8. The volume of cube B is 104. So we're going to go to the small one, so we're going to divide by 8. That's the scale factor. Let's go back over here. 104 divided by 8. And I get 13. So this guy is 13. So the volume of cube A is 13. And that is our answer. Great, let's move on to question 6. Okay, 2 circles. Let's draw a small one and a big one. And it sounds like B is the bigger one for this time around. So let's label that. And it tells us that the circumference is 3.7 times the circumference. Okay, so circumference we talked about is a linear measurement. So that is telling us the linear scale factor, which is equal to k. And the question's asking about area. So we're going to do the area scale factor, which is k squared. And I don't know what that is, so we can switch to fractions, but I mean, if it comes out nicely, I don't see any reason why we can't just do this. Okay, 14.0625, that's not too bad. I'll just leave it like that. Just whatever you do, just make sure you use some form of an exact answer. If you wanted to make that 225 over 16, you could do that. Okay, so now circle A has an area of 40. That is the smaller one. So we're going to multiply by 14.0625. So let's do that on the next line. 40 times 14.0625. And I get 562.5. And I believe that would be the answer. So the area of B is 562.5. That's 5 characters, so that would fit in the Blue Book app. 1125 over 2. That's 1, 2, 3, 4 / 5, 2, 6. That's 6 characters, so that would not fit. So using the decimal here would probably be better. Not a big deal. Okay, let's come back over here. Okay, these are some ones with the tables. These are areas, so we can deduce the area scale factor, which is equal to k squared by doing big over small. So the big area is 2268. Small area is 7. I don't know what that is. Let's see what it is. 324. And remember, the area scale factor is equal to k squared. So we need to take the square root of both sides to find k. And let's see here. K square root 324. We get 18. So k, the linear scale factor, is equal to 18. It's not the final answer, but that's kind of important. And question's asking us about sides. So we are going to use the linear scale factor because that's a linear measurement, side length. And parallelogram B is 75 inches. So to get the smaller one, we're going to divide. So we're going to do 75 over 18. And you could put 4.166666 until you run out. But let's see if it simplifies 25 over 6. Okay, let's put that 25 over 6. That's going to be our answer. The side of A is 25 over 6. Now, let's reset Desmos here. And I'm just going to do one final check. So K is equal to 18. So 25 over 6 times K, and then this is an area, so it's going to be times K squared. So 25 over 6 times K, get 75, looks good. Now let's check the original. 7 times K squared, and I get 2268, so it certainly seems like we did a good job with that. Great, let's refresh. Come back over here. All right, this one wants us to compute a volume scale factor. So we're going to do volume scale factor equals big over small. So in this case, it's 1620 over 7.5. I have no idea what that is. Let's see what we get. 1620 over 7.5. I get 216. And then remember, the volume scale factor is equal to K cubed. So we are once again going to take the cube root of both sides. To find K, I'm still not even sure if K is what we want. We might want K squared, but let's just find K just because that'll help. So we're going to do the cube root, CBRT 216. And we get 6. So K is equal to 6. The question's asking about height, so we indeed do want the linear scale factor, so we're going to use 6. Let's add the information to our picture here. So this is height. And the height of cylinder B is 25. Okay, so cylinder B is the smaller one, it looks like, so we're going to want to multiply. So 25 times 6, and that is 150. So the height of A is equal to 150. And once again, let's refresh and see, just to be certain we did it right. So let's make K equal to 6. And we're going to do 25 times K. And then 7.5, that's a volume, so we're going to do times K cubed. And we get 150 and 1620. So it certainly seems like we did a good job finding K and applying it to this problem. Great, let's move on to the next question. Okay, so width is a linear measurement. You can also tell by the units, guys, inches. See how there's no power or no square or cubic? So that means it's one-dimensional. The table gives the width in inches. Okay, so the length scale factor, linear scale factor, which is equal to K, we're going to do big over small. So 135 over 15. And let's see what that gives us. 135 over 15. That's 9. And this question is asking about area. So the area scale factor is K squared. So that is 9 squared, which is 81. Now we can probably start adding stuff to our picture. So let's make this area. And we're going to, rectangle A is 145.8. And rectangle B, we don't know. It seems like rectangle B is the smaller one, so we're going to divide. So 145.8 divided by the scale factor for area, which is 81. And we get 1.8. We still haven't answered the question yet, guys, so let's let's first check to make sure we did it right really quick. So if k is 9, 15 times k gives us 135, and then 1.8 times k squared gives us 145.8. So it seems like we did a good job with that. Now it wants us to find the positive difference in the areas. So we're going to do 145.8 minus 1.8. And I'm getting 144. So I think the positive difference between these two is 144. So just be careful, guys. There could totally be like a follow-up question that requires an extra step or so. Great. Let's move on to the final question. Okay, this is a challenge question. So first, notice that it says they are both equilateral triangles. Remember we talked about at the very beginning, equilateral triangles, just like squares, are always similar because they have the same shape, regardless of their size. So that's important. Now, this next thing, the ratio of AC to CE, that's this part, is 2 to 7. So a really kind of convenient thing you can do, it's not necessarily 2 and 7. So a really convenient thing you can do is just put x. So why don't we call this 2x? It doesn't matter anyway, and 7x. Now you see, if we break this into the two, the small and the big triangle, the small one has a length of 2x, but then the big one has a length of this entire side, 2x plus 7x, which is 9x. Now we have two corresponding lengths, so we can calculate the length scale factor. So the length scale factor, which we call k, we can do big over small, so 9x over 2x. Most people would have did 7 over 2 and gotten it wrong. 9 over 2, I'll just keep it as a decimal because there's no reason for me not to if it comes out nicely. So the linear scale factor is 4.5. Now this question's asking about area, so we need to compute the area scale factor, which is k squared, which is 4.5 squared. And let's start including Desmos in the mix here. So 4.5 squared is 20.25. So the area scale factor is 20.25. They gave us ADE. ADE, which is the bigger one. So we're going to need to find the smaller area. To do that, we're going to have to divide. So the area of the little one, ABC, is equal to 162 divided by 20.25. And let's go to Desmos and see what we get. So 162 over 20.25. And we get 8. So the area of ABC is 8. So now the question wants us to find the area of the shaded region. So you see, if the entire pink is 162, and then ABC we just found is 8, we can subtract them. So 162 minus 8 is 154. So you see, if we do 8 plus 154, we get 162, and the ratio that was given in the problem is maintained. So the shaded area is the total area, which was 162, minus the unshaded area, which is 8, and that gave us 154. So definitely make sure you understand how to kind of separate an overlapping figure into two figures, and also make sure you understand how ratios work. So really quick thing you can do is just put, okay, 2 to 7, let me just label those sides 2x and 7x. And you'll see here it's not going to matter anyway because the x's will cancel out when you go to find the ratio. Great, let's go back to the slides. Okay, thank you so much for watching my video. I hope you found it helpful. I worked really hard on this one. Please comment below your thoughts. Tell me what you thought. Tell me if you found the video helpful. Be sure to like the video and subscribe for more digital SAT math content. And if you need tutoring, my website is linked in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by and good luck studying.